everyone, welcome to watching lesson 15 of SuperKit for Arduino series video tutorials. How to use rotary encoder. Let's see the phenomenon first. Next, let's see the components to be used in this experiment. Send on the UNO board, rotary encoder, jumper wheels, and a USB cable. Let's see the principle of this experiment. There are two main types of rotary encoder, absolute and incremental. Here we use incremental encoder. An incremental encoder is a rotary sensor to turn rotational displacement into a series of digital pulse signals, which are then used to control the angular displacement. It generates two-phase square waves whose phase difference is 80 degrees. Usually the two-phase square waves are called channel A and channel B. It's difficult to distinguish left turn and right turn during SCM programming. However, when using an oscilloscope to observe the left turn and right turn of a switch, you will find that a phase difference exists between the signals of the two output pins. The phase difference is shown as follows. When channel A CLK is high, if channel B DT is high, the switch rotates clockwise. If channel B is low, the switch definitely rotates counterclockwise. As a result, if channel A is high, you can judge whether the rotary encoder turns left or right as long as you know the state of the channel B. That's all for the principle. We start building circuit. Select pin CLK to pin 2 of the board. Select pin DT to pin 3 of the board. Select pin SW to pin 4 of the board. Select its positive pole to power source and GND to ground. We start programming. Open IDE. Select pin CLK to pin 2 of the board. Select pin DT to pin 3 of the board. Select pin SW to pin 4 of the board. Define a variable encoder val to store the value of the rotary encoder. Define a static variable odd-A and initialize it as 1, used to store the states of previous paths from channel A. Then define a static variable odd-B, used to store the states of previous paths from channel B. Set pin 2 and 3 as input. Set pin 4 as input and configure it as pull-up. Initialize the serial port. Change is used to store the state of the rotary encoder. When rotating clockwise, it's 1. When counterclockwise, it's -1. If you press the switch, the value of the rotary encoder will be 0. If channel A or B changes and channel A falls, the variable result stores the state of the rotary encoder. When channel A falls and channel B follows, it means the rotary encoder rotates clockwise. Result is 1. Otherwise, counterclockwise. Result is -1. That's all for the code. Compare and run. If there are no errors, we download the program to the board. Open the serial monitor. Here we can see if you rotate the rotary encoder clockwise, the value printed on the screen gets bigger. If counterclockwise, it gets smaller. Thank you for watching. See you next time.